we have a separate slide. Okay, so as I mentioned, we have a separate slide for trail files. So by default, the trail files reside under dir dat. We have already seen it. The naming convention actually starts like this, ex, and then it will be 9 zeros. That means it always starts with 9 zeros and then it is an incremental, like at the end it will be 1. Okay, so for you guys, I have an assignment. Because I'm on this slide, I'm telling you what will happen if all the sequences are exhausted. Okay, this is your assignment. Write it down. What happens when all the trail files sequence number completes? Like you have ex and 9 times 9, 1 2 3 4 5 6 7 8 9. So what will happen at this stage? This is your assignment. Any which is, I'll be sending an email for your assignment. Okay, that is something you have to figure out. So this is the naming convention. And also guys, don't get confused like our report files. Report files work in the reverse order. That means in the report file, if you see 1 at the end, that means it is old file. But in the trail file, it is a normal sequence number. That means the latest one or the maximum number that you see in the trail files, that is the one which is the latest. Let us try to get inside this dir dat location. Now can you see we have ex 9 times 0 and ex, this is 1. Also we had second replication where our trail file name started with e2, that is our second replication. Again 9 times 0 and this is 1 at the end. So if you like bounce the process, then definitely a new trail file will be generated. We'll try to do it. Info all. So I will stop ext1. Still running. Okay, now it is stopped. Let us start ext1 again. Okay, it's running, right? So cd dir dat. Now can you see new file ex00002 has been created. So whenever you bounce your processes, a new trail file will be created. Also, the default size is of 500 MB. Okay guys, one point just to mention over here is in 11G we had 6 digits to the trail files. 12C has 9 digits. Okay, in 11G this was one limitation. We had only 6 zeros. So it was very easy for the files to fill up with the 6 zeros, but with 12C they have extended it to 9 digits. Now that practically comes to 1 billion trail files. That's a good number. I don't think people can touch that number so easily. But that's the assignment you have. What will happen if the sequence number is exhausted? What you should do? Okay, so you have to come up with that answer to me. Next one is default size is 500 MB. So what happens when 500 MB is reached? It will move on to a new sequence number. Now the max size that you can increase, the default is 500 MB, but max that even I have heard or I know is 10 GB. I don't know about 12C. I think there is no change over there. It's 10 GB only. So the default size is 500 MB. There is no, if the file is full at 500 MB, then it will move on to the or roll over onto the next trail file. It's written, okay, whenever 500 MB is full, new trail file is generated. Whenever you restart the process, new trail file is generated. This example we have just now seen. Okay, last 2 slides. These are good to know slides and some good data. good stuff you will get to know about Golden Gate. Maybe a lot of doubts that you guys have asked me earlier, those all will be cleared in these slides. So I will take little time to explain this one because there is a lot of important stuff over here. So the first one is distribute load on Golden Gate process. So how can you do it, and also whether it is good to do it or not. We'll consider some scenarios and then I will jump into the conclusion. See guys, how to distribute the load in case if you want to. Example, I'll try to just give you some examples. We have this extract process, right? Extract is extracting 10 tables. So what you can do is you can actually create two pump processes, DP1 and DP2. So this way what happens, this one will work on 5 tables and this one will work on 5 tables. Then you have replicat 1 and then replicat 2, which are again pushing the data into the target table. This is one example, just a random example. It again depends on the scenario, it depends on the environment, it depends on the memory utilization, it depends on the amount of transaction you have. Actually, we were supposed to see one more activity today, that is how to define total number of Golden Gate processes. We'll see if time permits, we'll definitely look at it. So this way, now let us assume there is a lot of pressure onto the extract. So what you can do is you can increase the extract. The first one is having 5 tables and again second one is having 5 tables. So this way it will work as a parallel setup. So again, it depends. So this is how you can distribute the load. Also, let us assume you want to increase the speed at the replication end. Over here in the first example, we have increased the speed at the data pump level. That means pushing of data will be fast. Okay. Now we can do like this. We have one extract and then we have one data pump. Over here on the target side, we have 2 replicats. We can have it like that, like this. So this way we are increasing the speed at the target level to implement or to replicate or to push the transactions as fast as possible into the target DB. So again, it depends where you want the speed. Do you want the speed at the extract level? Do you want the speed at the data pump level? Do you want the speed at the replicate level? Where you want the speed? And depending on that, you increase the processes. Again, there are pros and cons of increasing the processes. You should not do it blindly. There is again a theory. I wanted to discuss about it. So I'll talk about it in some time. The topic is how to define total number of Golden Gate processes. So yes, we can distribute the load on Golden Gate processes. That's one of the beauty about Golden Gate. If you feel that something is slow, you increase one more process. If you feel something is further slow, you increase one more process. Next is parent-child tables must not be distributed. Sorry for typo. Parent-child tables must not be distributed on different processes. Okay, anybody wants to take a guess as to why we should not distribute the parent-child tables on multiple processes? Any guesses?
Same constraint?
Yes, correct. You're right. It is because of the constraint. So I'll talk about it. I'll give you a very small example. I think you guys will understand. Now assume in Scott we have scott.emp and scott.dpt. Now these two are parent-child table. So this one we have configured on extract 1 and this one we have configured on extract 2. Now assume on the target side, because this contains a parent-child relationship, it's having a lag of 3 seconds, but the extract 1 is having a lag of 10 seconds. So what exactly is happening? Our child record is being delivered before the parent record is being delivered. So if you have this kind of configuration, it will throw an error because it's a constraint error. On the target server, let's take we have an insert in both the tables, but the insert in department reaches over there first. Then it's a problem. First parent record should be there, then the child should be there. So that's why parent-child tables which are related in terms of constraints must not be distributed. You should not distribute them. Otherwise, you will always be caught up with the constraint errors. So don't do that. Now this again comes as analysis before you implement Golden Gate. Before you start implementing Golden Gate, you need to analyze the tables. You need to understand the amount of transaction. You need to understand what are the critical table, non-critical tables. Then you need to understand in the critical tables what are all tables which are related with the parent-child, or any other constraint relation or foreign keys. Then you need to group them in one extract, and that's how the entire designing happens in Golden Gate. Next is process names, maximum 8 characters, and maximum you can have 256 processes. Yes, you can have 256 processes inside Golden Gate, but I don't think anybody will use so many processes because each process takes its own memory. Each process again takes its own CPU, and also each process will again, if in case it is extract and replicate, they will take your database SGA also. So the more you have, the more memory you need to have. So that's again a constraint over there. In the design part, you need to again consider whether you really want to go with so many processes or you can reduce the number of processes. If you want to comment something in Golden Gate parameter file, just use double hyphen. Now make changes in the parameter file. How to make the changes? Stop the process, edit parameter file and start the process. Very simple. If you edit the parameter file while the process is running, it won't take in effect. Each process can write data less than or equal to source data. Wow, this is something important and you should know about this one. Okay, it's actually self-understood, but I still want to stress on this one. So let us assume we have extract process. Okay, extract is extracting 20 tables. Now data pump, Now the data pump can push equal to 20 tables or less than 20 tables. Why? See, I can have all the 20 table pushed by the data pump process, or I can have two data pump processes which are pushing 10 tables. Can happen, right? The same example we have seen earlier. So each process can actually push the same amount of data or less than that data, but not more than that. We cannot have this data pump sending 21 tables. Do you think it is possible? I mean, because the source of the data pump is having 20 tables, so how can you send 21 tables? Remember, we define three things for every process: input, output, and then parameter file. Input is 20, then how can you go beyond 20? You can go less than 20 or max you can go till 20 tables. The same thing happens with the replicat. If you are getting 20 tables from the source, then replicat also can replicate only 20 tables. It cannot replicate more than the number of tables. I mean, self-understood statement, but still I wanted to stress on this one. So each process can write data less than or equal to the source data, whatever their source is, the amount of tables that are coming. Max it can write those many tables, but it cannot write its own new tables over there. Okay, I'll tell you something new. Once what happened, we were trying to replicate one table. Okay, I'll just take an example, scott.emp. Just an example, but this was available in the parameter file of the replicat. This was not available in data pump. This was not available in extract. So definitely replication will not work. It happens. You might miss some time. So the design team forgot to add the scott.emp in the extract. So if you try to add tables which are not at all being extracted, so nothing will work. Okay, these all are good to know information. So we have few more. All the table mapping is done using the replicat. Where do you map the tables? If you remember, in the replicat parameter file we defined, right? Map. there is a parameter map, we have source, and then we have target. Correct? So all the data mapping happens in the replicat. This is something you should know. Again, I am repeating, this is data mapping. And again, if you remember, I mentioned this point, all the data transformation should be done in pump. Correct? Data transformation. Sorry for my writing. Okay, data transformation, why we should do in data pump? Because we might say that after the transformation of data, the data size might reduce. So we have less data to be pushed onto network. So that way we are reducing the network load. Correct? So data transformation should always be done in data pump. Again, you can do it in replicat also, but the mapping is only done in replicat. Next, start troubleshooting from extract and then move forward. If there is an issue, for example, I mentioned that scott.emp was not getting replicated, just an example. So I will first check whether extract is extracting this table or not. If it is not extracting, simply it means that it will not work. So you should move your troubleshooting from source to target like this, in this direction. So that way you will be able to find the solutions. I mean, I'm just in this slide, I'm sharing all my experience. Just you guys can follow it. Okay, you can kill the Golden Gate process from OS level as well. So let's take, in case there is an issue, and you can do ps-ef grep. Sometimes the Golden Gate processes will hang, and it is very hard to stop them normally. So like how we kill pmon, the same way you can also kill Golden Gate processes. The process is same. You just grab the details and kill the process. And each Golden Gate process takes approximately 25 to 50 MB of memory. Okay, I think I have a link for this one. Let me show you something. If you go to the blog, can you see how to find Golden Gate process memory usage? I have put up a script. I mean, the script, you guys can use it. So each and every Golden Gate process takes approximately 25 to 50 MB of, I mean, it can take even more than 50. That's the general one. So 25 to 50 MB of memory, or sometimes more depending upon the transactions. Here is one script which will help you find total memory usage on source and target server. This script is written for Linux. It's a Linux script. You can just copy, and this is how the output would be. Let me show you. Can you see this is on ggprod? If you run the script, this is how it will give you the output. dp1 is taking 34 MB, ext1 is taking 49 MB. So total extract process usage is 83 MB. And total replicat, definitely you will get an error. Why? Because on the source we don't have any replicat process. So ignore the error at the end, as there is no replicat details available on source server. So when you run the same script on target, you will get error on the extract because there is no extract onto the target server, right? But you can see 34 MB is being used by replicat. So total memory usage is 34 MB. I think this will help you. If you guys, I think somebody was asking me on email, is there a way to find the memory usage of Golden Gate? So that script will help you guys. So simple, you go to the blog, you can see it on the top. You can click on blog, and on the blog you will find this one. So each Golden Gate process takes approximately 25 to 50 MB memory. And the best thing is why we are stressing so much about good to know things, because the more better design you make, the good design that you make, the less errors you will get, and the more performance or the greater performance you will have. If you have a poor design, what will happen? A lot of performance issues, lot of other issues in real time, and it will be hard for you to manage your environment, right? So I think we have few chats. Okay, so Hitesh, if both DBs have different characteristics, character set, then will Golden Gate automatically take care? I think we need to add a parameter to, take care of that one. I'll check on this because typical doubt, but I have never seen this situation. As far as I know, once we had this issue with database, but it's my bad luck because most of the environments I have worked, the character set was never an issue. But good one. I'll check on that. Okay. Support my DB performance is affecting due to Golden Gate. Then what info will I get in a... So this one, Hitesh, will hold on for the Golden Gate performance tuning. You're talking about the impact of the Golden Gate. Yes, we have a lot of things. As I mentioned, this is not a 100% course, guys. We can't get into the full Golden Gate performance tuning. We can't get into many other areas. I can actually give you a relative information which can help you to further, kind of deal into it. So yes, we'll be looking about this information, like how Golden Gate is affecting your database in the Golden Gate PT. Okay, any further questions, guys? Actually, I have one more topic. The problem is it will take more than half an hour to complete. It is about how to define total Golden Gate processes. So I'll push it on to next session. So what is your homework or what is your assignment for this week? First of all, you need to complete all the replications, single table replication, and then yeah, that's it. We have 3 replications that we have seen, right? 2 replications I have shown on the live session and 1 is your assignment. Then I want you guys to find out what happens when all the trail file sequence numbers are complete. So what will happen if all the sequence numbers are done? What happens after this one? Does trail file create a new sequence number with 10 digits, or as a DBA, what action you have to take? Okay. I think I have few more assignments. I have written it somewhere. I need to check it. I'll send an email about your assignments. Please be serious about assignments. Try to finish them as far as possible. So guys, open for all. If you have anything, let me know. I'll make a note about the character set. I'll check about it, Hitesh, and get back to you.
Hey Arun, I have a question regarding the collector process.
Tell me.
When actually the collector process gets started, as soon as we start the manager, then it gets started?
Okay, when the data pump is sending the data, then it will be started. Then actually it is like in a waiting state when you start the manager, but it becomes an active state when the data pump is sending the data.
So does that mean that collector process actually resides in waiting state on both the servers?
No, only on the receiver it will work, right? So if you configure the reverse configuration, if you configure the bidirectional replication, when we'll be working on the bidirectional replication, then you will find it over here. Then you will find it on the source as well. Because see, where your target trails are there only you will have collector, right? On the source, did you see any target trails? No, right? No remote trails. So you won't see the collector over there.
Okay, fine.
Yeah. Any high availability kind of rack in Golden Gate? Yes, we do have high availability setup in Golden Gate. You set up high availability using Golden Gate. And there is nothing called as rack on Golden Gate, so that Golden Gate is highly available. I think I have never seen it. You set up, like using rack, you set up high availability. The same way using Golden Gate, you set up high availability. There is no high availability on top of Golden Gate. Okay. So guys, let's meet next weekend, same timing. If you have anything, send me an email. Till then, take care. Bye-bye.